So for this problem, we're going to see if this is continuous on these three different separate intervals. So we're going to check each interval one by one, and this is a piecewise. So if we're going from -1 to 1, that would be from this function, because this is less than 0, to the middle of this, or part of this function. So we're talking about these two functions here. We know this function is continuous. We know this function has a discontinuity. Where does tangent have a discontinuity? Well, tangent x is equal to sine x over cosine x. So we know there's a discontinuity when the denominator equals 0. So when does cosine equal 0? It equals 0 at pi over 2 and 3 pi over 2, but that's outside of it. So it's just at pi over 2. That's the only spot it is discontinuous on this particular interval. Okay, so that would be an issue. Well, is pi over 2 bigger or less than 1? Well, it's actually bigger than 1, so we can ignore that one. So all we got to care about is, do these two functions meet at 0? So how do we tell if these two functions meet at 0? Well, what we have to do is we have to find the first function at 0, and we have to find the second function, which I'm going to call it sine 0 over cosine 0, because we know that tangent is sine over cosine. So the first one here is 1, so that coordinate is 0, 1. And then this one is going to be 0 over 1, which is 0. So this would be 0, 0. So since these values are not the same, these two graphs are not going to connect. And so this would be a no. It is not continuous on this interval because the two edges of these at 0 do not connect. Let's look at the next one, from 1 to pi. So from 1 to pi would be in this interval. The whole thing is in this interval. So you're going from 1 to pi, so the middle of this interval to the end of the interval of tangent. Now we already found that tangent has an error at pi over 2. We know that. So okay, so pi over 2 is pi over 2 in this interval. And you might wonder, how do I know? Pi over 2, I don't know. Well, pi over 2, isn't pi about 3.14 over 2? So if we approximate that, isn't that going to be about 3 over 2, which is about 1.5, about. So is 1.5 in this interval? Yes, it is. So guess what? There's going to be an asymptote in this interval. So guess what? This discontinuity is in the interval, so guess what? This is a no as well. It is not continuous on that interval. All right, if I went from 2 to pi would work. Again, if I went from 2 to pi, that would work, because 2 is above this, and it would be continuous on that interval. But I didn't. So number 6 here. Letter C here, sorry. From 4 to 6. 4 to 6. 4 would be starting in this one, starting in secant, and ending in this one. So what we first want to do is, does secant have any issues on this interval? Or we can also check, do they meet? Either one. Let's first check and see if these meet. All right, do they meet? Let us see. So let's say secant is 1 over cosine. So 1 over cosine of 5. That's interesting. What is that going to be equal to? And the next one is going to be 3 over x plus 1. And what am I going to have for x here? I forgot. I'm going to put a 5 in right there. So what do I get for this one? This becomes 3 over 6, which is 1/2. And this one becomes 1 over some number, some decimal. But that decimal would never equal exactly 2. So I know these aren't the same. I know they're not the same, so guess what? These don't meet. So I know right away this is not going to be continuous. I don't even care about the discontinuities for secant. I mean, yes, there could be a discontinuity on secant on this interval too, but we know right away just by this, we know it's not going to work, so this one is also a no. Now a couple extensions we could think about is, isn't there a discontinuity at -1? But guess what? -1 isn't in this interval, so this -1, this asymptote that goes right here, isn't even on this interval, so we really don't even care about it. Okay, awesome. Let's see, again, secant and tangent actually both have the cosine on the bottom, so actually they would have pi over 2 would be an error for both of these. But you'd actually add more because pi over 2 for secant, pi over 2, but you actually have to go farther, which would be 3 pi over 2 would jump into this one. 3 pi over 2 would also be an error on this one you have to consider. Basically, when you're doing piecewise, you're looking for discontinuities. You look at each one by one. Do they have errors, but errors on the interval? Remember, this one had an error, but not on the interval. And then you have to make sure these connect at 0. These connect at pi. These connect at 5. And there's a lot of things you have to pay attention to see where discontinuities are.